In TEF2, we focused on flexible cobots with plug-and-play modularity and smart, intuitive programming. We test these capabilities in a real case, electrical panel assembly, where the robot handles repetitive pick-and-place tasks while the operator focuses on higher-value work. In Challenge 3, we developed a system that can actually observe the operator through a camera and reconstruct their body movements using ROSE 4 HRI body tracking modules. This allows us to calculate ergonomic indices in real time while they perform the task. All this data is then streamed into Fireware, so we can store it and visualize the trends directly in a Grafana dashboard. In the video, you can see some validation with some pose and ergonomics index results on Grafana changing in real time. And to make the entire pipeline easy to reuse, we packaged everything inside a Docker Compose environment, so it can be deployed quickly and consistently in future setups. In Challenge 4, we adopt new robot control library using Pinocchio with a new voice-based interface for intuitive programming. We start providing operators ability to issue simple commands like move up or move left, and LLMs translate those voice inputs into actual robot instructions, making programming faster and more accessible. In the video, it's possible to see the first tests in simulation environment. Using Whisper AI, the system is able to convert the operator's speech to text and then send it to the robot control to make the movement happen. In this slide, we show the high-level architecture for Challenge 4. The operator interacts through voice or text, and ROS 4 HRI extracts the intent. Based on that intent, we can enable robot control, saving poses, building routines, and making them executable later. Here we show the main intents and skills defined for the demonstrator. Based on these, the LLM generates the appropriate output, which is then structured as a JSON, like the one shown here. In this video, we see the demonstrator in a simulated environment, where our system integrates all the technologies developed in ARIs. You can observe both the robot components and the intuitive voice-based interface. In the bottom left panel, it's clear how the operator interacts using voice commands to trigger different skills, like save position. From these commands, the system automatically generates a JSON representing the routine, which can then be executed in the future.